Here are 10 Python tips to make your code better and more Pythonic. Number 1. Guard clauses technique. Nested if statements can be really hard to read and maintain. And the more if statements you nest, the harder it's going to be to read and understand. We should use the guard clauses technique instead. In this code snippet, we see if a user is connected to Wi-Fi, logged in, and is admin, then he can see the admin panel. Otherwise, we print out an error message. In order to know which else corresponds to which if, we have to jump around between if and else, which makes it really inconvenient, especially when we write more code inside the if statements. If we reverse the condition of the Wi-Fi and say if there is no Wi-Fi, we can put the nested code right under. Then we'll print out an error message and return. Then we do the same thing for the login condition. And lastly, we do it for the admin condition. After we pass all the conditions, we can call the cAdminPanel function. Now the if statements are more readable and maintainable than before. Number 2. Enumerate. If you have to loop over an array while keeping track of an array index like this, you can do it in a more Pythonic way by using the enumerate function. The enumerate function returns the index of the array and increments it for you, saving you 2 lines of code while making you look more professional. We can also make the index start at whatever number we want by setting the start parameter. Here I will set the start parameter to 1 instead of its default 0. Number 3. Formatted strings. Here is one famous way to embed variables in a string, but a better way to do so is to use the formatted strings. A formatted string is defined by an f before the string like so. Then we can refer to any variable by surrounding it with curly braces. We can see that both strings are the same, but the second way is more Pythonic and provides you with multiple useful features. We can add commas to a large number to make it more readable by simply adding a colon followed by a comma. You can now read that big number with ease. We can also limit the numbers after a decimal point by writing dot, then the count of numbers you need after a decimal point, followed by an f. Now the second number only shows 2 numbers after the decimal point. We can also ensure that a variable reserves a specific number of characters. So let's say we want the third number to reserve 3 characters. Specifically, we want to show 003 instead of just 3. We can write a colon, then any symbol, a right angle bracket followed by the number of characters you want the string to reserve, and it will fill the remaining space with a symbol to the left. Now we can do the same thing with a different symbol on the right hand side by switching the right angle bracket with a left angle bracket. And we can also surround a variable with a symbol like so. Number 4. List comprehensions. Let's say I want to create an array that takes each element of this array and multiplies it by 2. This code works fine, but we can do it in a more compact way by using list comprehensions. This is the same for loop but is written in a more compact way. Here we loop over each element and multiply the element by 2. We can also add an if statement like so. This if statement checks whether the element is even. If it is even, then it will be included in the new array, else it will be disregarded. We can also do that with dictionaries. We just put curly braces instead of square brackets and provide a key and a value. List comprehensions can make your code more compact and Pythonic, but overusing it by trying to put long complicated loops in one line can make your code unreadable and more complicated. So use it wisely. Preferably, only use it for simple for loops. Number 5. Unpacking. In Python, you can assign multiple variables in one line like so. This makes it really efficient in declaring variables. We can also return multiple variables from a function and assign the returned variables like this. If there is an element that we won't use, we can put an underscore in its place and it won't be assigned a variable. Number 6. The zip function. The zip function takes in multiple sets of data and zips them into one iterable object. So let's see how that works. We have 2 arrays here that we want to iterate over. We can put the 2 arrays in a zip function and you will get an object with 2 elements like so. The element at index 0 will be the first array, and the element at index 1 would be the second array. You can also conveniently use unpacking to give each element a variable of its own. Number 7. Opening and closing files. Here is the simplest way to open and close a file. We can use the open function, then give it the file path, and tell it to open it in read mode. Then we can read all lines by calling the readLines function. And finally we close the file. But if there's an error or a bug between the open and close functions, then the file won't be closed. To handle that, we can put the code in a try and except statements, but this is not the preferred way to do it. It's better to use the with keyword instead. We write with, then open a file, then write as, and give it any variable name. My variable name here is file. We can then go ahead and read the contents of the file and do whatever we like. The file closes when we exit the with statement, and it also provides a layer of protection that closes a file if an error occurred. Number 8. Glob. We learned how to read one file, but what if we need to read all files in a folder? We can get all the file paths in a folder and loop over each path and read the files one by one. The glob function helps you get all file paths in a simple way. We will need to import it first, then call it and give it a folder path followed by any regex expression to select specific files. I can write star, which means all files, then .txt, which means to get all files that ends with .txt. We can run it and see that it listed all text files in that folder. Let's say we have a folder that contains multiple folders, and inside each folder we have .txt files that we want to read. We can tell glob to go through each folder by writing ** and setting recursive to true. If we run it, we can see that it got all text files in the two folders. Number 9. The sorted function. Sorting in Python is really easy. All we have to do to sort an array is to call the sorted function like so. We can also sort more complicated arrays like this one. Let's say we want to sort this array depending on the first element in the tuple. We can do this by creating a function that takes in one array element and returns a value to sort the array on. Here we return the first element of the tuple. Then we provide this function to the sorted function in the key parameter. We can see that the array was sorted depending on the first element in the tuple. We can also sort it depending on the sum of elements in the tuple. All we have to do is go back to the function and write x of 0 plus x of 1. The sorted function will get the sum value and sort the array accordingly. Number 10. Lambda functions. In the previous example, we defined a function exclusively to pass to the sorted function, and it was used once in the code. We can save some space and make our code cleaner by using the lambda functions. Lambda functions gives you the ability to define anonymous functions in one line. We write lambda followed by our inputs, then a colon, and finally our output. Here we define our output as x of 0. When we run it, we see that we got the same output as before. We can also change the output to x of 0 plus x of 1, and run it again. When we run it, we see that the sorting behaved as expected, sorting elements depending on the sum of the tuple. If you found this video helpful, give it a like and subscribe for more Python content.